Hi, my name is Guan Wei, and right now I'm going to talk about the design of the low-pass butterworth filter. So in this case, for here in this lab 8, for the question 1, it requires us to design a minimum order stable with the low-pass butterworth filter with a passband frequency of 1 kHz and stopband frequency of 1.4 kHz, and then we gotta make the attenuation 1 dB at the passband frequency and then 80 dB at the stopband frequency, which means that any power or any dB that is more than the 80 dB would not be accepted. So in this case, we're gonna open up the MATLAB. We're gonna type in the FDA tool, and after typing the FDA tool, we're gonna have this filter designer here, which is the graphical user interface. So as we mentioned just now, as we have read from the question just now, we have to design it in a low pass, and it is also the butterworth, which is also the IIR, and this is the minimum order. Nothing to be focused on. The things that we're going to focus on are the sampling frequency, which is the 1000. For the passband frequency, it's going to be 1000, and the stopband frequency is going to be 1.4 kHz. 1000, yeah. And then for the attenuation, which is the A pass, and for both the stop and also the passband, which are the A pass and the A stop, it's going to be A pass is going to have 1 dB and A stop is going to have 8 dB of the attenuation. And then after that, we just simply press the design filter down there, and we're gonna get the frequency output here. And then to check or to verify the order of this design filter, of the graph here, we can just look on the current filter information, which is right on the top left side here. It says that is it stable? Yes. Which section is it under? 13. Which order is it under? 26. And the structure is part of the direct form to second order sections.
I will present how to design a low-pass IIR filter with Chebyshev type 1 with a passband frequency of 1000 Hz and a stopband frequency of 1400 Hz. At first, we need to open MATLAB and type FDA tool in the command window. After the graphical user interface is open, the response type is set up with low pass, the design method is set up with IIR, and the Chebyshev type 1 is chosen. Filter order is minimum order. It will match exactly and passband, and the frequency specification, the frequency sampling frequency is 8000. And the passband frequency is 1000, and for the stopband frequency is 1400. For the magnitude specification, the unit is dB, and the attenuation at the passband frequency is 1, and for the attenuation at the stopband frequency is 80. And we click the design filter. The frequency order will shown at here. In this case, the structure is direct form 2, and it is a second order section. The order is 12 and the section is 6. The stable for this frequency order is very stable. That's all from me.
I will present about how to design a low-pass FIR filter using Blackman window with a cut-off frequency of 1 kHz. To bring out the FDAT graphical user interface, we need to type the FDA tool in the command window. After opening up the graphical user interface, we need to choose the specifications that already given in the questions, which the response type is low pass, and the design method is FIR, which we need to choose to the window, and the option for window we need to choose for the Blackman. And for the filter order, we need to specify order to 60. Then for the sampling rate is 8000. and the cut-off frequency is 1000. Then click the design filter. This is the magnitude response of the low-pass FIR filter using the Blackman window. You can see that the order of the filter requires such that the first minimum in the stop band is as close to 1.4 kHz as possible without exceeding it is 59 orders, and the filter is stable. That's all from me. Thank you.